Hi, yeah, this is a talk about SSH and somewhat advanced topics on it. You know the hashtag and my Twitter handle. If you want to poke fun at me or have questions, use the social media things to get a hold of me. You will get the slides, so there's no need to take photos, but of course you're free to do so if you want. If you have questions, please just raise your hands during the talk. That's fine for me. And we'll see what we can do. Yeah, peculiar SSH, some advanced topics. Of course, I don't know everything about SSH. I'm still working on that. And as always, SSH is an infinite topic. You can never know enough about it. If you might be scared by some of the things you'll see in this presentation, there's a beginner's workshop for everyone on the spectrum. Please join me in From Zero to Hero or to Heroing. If you want to begin with SSH and get a good start with a good foundation, you can build upon. The workshop starts at 1600 in the workshop room. And I'll be getting some help from Hetty to get you through this. OK. Everything is certified, 90-11% to work on my machine. Your specific distro or operating system might have some differences. We'll see about that. There's a few updates on last year's talk from BalCCon, and you may have been at B-Sides Ljubljana as well and seen my presentation there. Here's a few updates on two-factor authentication. We've been into depth last year on that, so I'll not repeat that, just watch the video. It saves us all time. There's still pictures of RSA tokens for two-factor authentication on the interwebs. These are new ones, not the ones from last year. You can show off your reading skills or use the Raspberry Pi that has been collecting dust on your shelves. People actually do this. You can easily find them. Please be not one of those persons who do this on the internet. There's still simple time-based one-time paths. There's free applications you can use on your smartphone, which means it doesn't cost you anything to implement this. There's, of course, on the left, the Google Authenticator icon for iOS. In the middle is free OTP. It's for Android. It's available on the Google Play Store and on F-Droid. And the other one is a commercial product that also implements this. It's commonly referred to as Google Authenticator, but it's actually an RFC standard. It's 6238, and so it's interoperable between all the systems. If you like to spend some money on hardware tokens, there's some bad news, meaning if you have some FIDO U2F standardized generic second factor tokens, they do not work with OpenSSH, which is sad. There's some discussion going on since 2015 to support them. I hope they will become supported at some point, but I would not count on it anytime soon. They're about 20 euros, 2,500 dinar for you. Other models like this one, they're more expensive, $40 to $50 or euros, around 6,000 dinar. They can be used as a HMAC-based authentication token. So this one you can use with OpenSSH. And there's also a standard to support this in RFC 4226. So you can count on that. And you can mix and match authentication methods in SSH. So this example is, of course, ridiculously stupid and not helpful in reality, but you can require two different public key authentications and a hardware token, for example. Of course, do something that is more correct on the real use case. If you want to use Google Authenticator, you can either scan the code with a barcode or type it in manually. In either case, please test if this works before requiring the second factor. I've actually had a presentation where we did a live demo with Google Authenticator, and we had bit flips by scanning a QR code which already has error correction. And we got incorrect codes on one phone and the correct ones on another one. You can lock yourself out if you require them immediately. Of course, this has never happened to me. Yeah, crypto config update. Last year, we did a in-depth info on how to correctly configure your cryptography in SSH client and server, mostly client. I'll not repeat that again. Again, watch the video from last year. There's just a small update since the world changes. This is the ideal world edition of this year. So if you control both the server and the client, these are some things you can actually use today. For server host keys, we all know SSHD config has this part in it in pretty much any distribution you may find. There's 4 lines for host keys of the server, and they're all commented out. Which of them are in use? Hands up. Who knows? RSA?
RSA, ED, 25, ED.
Yeah, the last one. Actually, all of them are used. If everything's commented out, all 4 are in use by the server and will be presented. So if you want to limit your server to only present modern cryptography, just uncomment a single line with the ED25519, which is the current recommendation for secure crypto.
RSA is good as well?
RSA may be required if you have to support older clients, older meaning older than 6.4, which is quite dated by now. And also ED25519 is elliptic curve crypto, which means it is fast, it is faster than RSA, and it's also fast on small machines like single board computers, your Raspberry Pi, your smartphone, any ARM processor. This is really fast handshakes, so that's quite a convenient thing.
All machines as well?
Well, if you have 6.4 or higher on the server, you can use ED25519. If you don't, RSA is the fallback you have to use. As for key exchange algorithms, yes, this is a very limited set. I recommend going only this way if you can actually support it on both sides, but this should be it. As for public pub key accepted key types, this means when you use it on the client in your config, this is the public key algorithms your client uses to authenticate against the server. So this means your identity file in your config. If you only allow ED25519 certificates or keys, and you configure an RSA key in your config, your client will blatantly ignore that RSA key because it's been instructed to only use ED25519. It's a good way to find out old configurations, and because they will just break. Convenient, isn't it? This one accepts certificates and public keys. As for message authentication, of course, the recommendation is to have an authenticated encryption with additional data. If you can't use that, you need a message authentication. The recommended ones for this year are HMAC SHA-2 series with encrypt then MAC, the only secure ones. This is fine to use. And as symmetric ciphers go after your handshake has taken place, I would personally go in this direction, CHA-20 Poly 1305. It's a really fast cipher. It's authenticated encryption, which means it does not need an additional MAC. It's all in one step. It's really fast. It's also fast in software. It's constant time implementation, so there's pretty much no way of side channel leaks and timing leaks. And it's also working very, very well with ARM-based systems, meaning you can SSH from your smartphone, and it's still pretty fast and performant. And with AES in GCM mode, it's the same thing. If you run any pretty much current Intel-based machine from 2010 or later, you have AES native instructions, which means it's hardware accelerated, it's extremely performant. And also AES GCM has ARM support with the Neon extensions, so it's mostly hardware accelerated on most platforms. So these are the ones to use there. An update to Bastion hosts or jump hosts, meaning you connect from your SSH client to like a firewall and jump over that firewall to the final destination server you actually want to reach. We did cover that as well a lot in last year's presentation, but I got the question of how do I use multiple jump hosts if I have the need? For example, I can reach the main office from a branch office or from my home workstation, but I'm not at home and I need to jump to my home workstation first and then to the branch office. Yes, you can easily do that. The standard configuration is you put in the configuration line proxy jump and then the configuration of your jump host. You just configure a standard host block in your config as you always do and use it as a reference. It's very easy to use. It's available from SSH 7.3 and above. We're currently on 7.5 with 7.6 coming any day soon now. And if you want to use multiple jumps, you just give it a list of all the hosts it has to jump through in the order it has to be done. Just a comma-separated list. And if you need to change this on a case-by-case connection basis from the command line, you can always override things in your config from the command line. So it's SSH-J and then the jump host to your destination. Yep, that host is in the 80s or 90s. Of course, there are legacy systems out there, otherwise known as the real world. And this very forward-looking recommendation for an ideal configuration does not always apply to the hosts you actually have to deal with. We all have this ancient Solaris box or AIX or Next Step somewhere in the basement. I still run Silicon graphics in production on some machines. It's weird. And of course, with a very forward-looking modern crypto configuration, you will run into problems and connection issues. Some connections will just break and not work. So how do you deal with those? If you have set some defaults, you can put overrides in your config. For a vintage box, you just specify the key exchange algorithms that one does understand and works. Of course, with newer releases of OpenSSH, and OpenSSH is deprecating bad crypto and old crypto and bad handshakes very strongly now. So in the future, you will have problems connecting to these. This is just an example. Thanks to two people, Kuchen and Puchi. They helped me debug my brain yesterday with a problem I had with that, and I will let you in on my mistakes so that you don't have to suffer as well. Yeah. Debugging. If you run into problems with connecting because your client is so super secure and modern configured, why not connect? How do you debug this? There's a lot of stuff accumulating in your config over the years. It might end up with 1,000 lines, and who knows what is actually applied to a connection now. How do I find out? Surprisingly, many people don't know about -G when you connect. You just say SSH-G and the connection you want to use. This will not try to actually connect to a host, but it will output all the configuration directives SSH does apply to that connection. So you get a long list of host blocks and match blocks and asterisk blocks from your configuration, and this is the final thing that SSH actually uses to connect. And then you will see why your configuration might not end up with what you have configured, so you can easily find bugs in your configuration. For example, I tried to connect to a vintage box, and it tells me, oh, well, I'm unable to negotiate with that machine. I don't have a matching cipher. For all the crypto settings, there has to be at least one overlap from the server and the client. It's a common concept, that's you know from elsewhere. Luckily, SSH gives me a nice error message like the offer from the host was these ciphers. And you say, well, I've got a default. I'll just override that and say ciphers, this one, and put it in my config and try to connect. And it won't work again. And I'll say, OK, give me what you're doing. And it still tells me, well, I'm applying the default you set. It's CHA-20, and the box wants to have AES CTR. Why doesn't it work? Because the order of your configuration file matters. The configuration files are scanned from top to bottom. and the first line that specifies a directive that matches your connection will be used, and it will never be changed if there's any other things in the configuration past it. So if you put host asterisk to set defaults at the top of your config file, that's nice, but you've already fixed the ciphers direction there. And the ciphers line in the vintage box host block never gets applied because that is already set. So it's easy to fix. You see the plus, it's ciphers plus AES now. SSH offers to add ciphers or add key exchange algorithms to the default set. And this is where I really, really tripped over for some time, because if you configure it that way, wouldn't you expect to be CHA-20 and AES now? I did, and this is a mistake, because this is what I ended up with, what my client would actually try. And there's 3 triple tests and AES in CBC mode. Where do they come from? I did not configure that. And we actually found out, actually Kuchen, he found out, it's actually documented that if you add ciphers, they're not getting added to what you have, but to the default set, which is hard-coded in OpenSSH. And the default set is pretty nothing you really want to use these days. Surprisingly, but that's what happens. So it took me a while to debug my brain, and I got help from friendly people. Yes, it is correctly documented, but it's a stupid default, and it's unusable in practice, and you can do better. So something to help yourself not trip over your own configuration is put it in the correct order. The more specific host configurations go on top, and the more generic ones, like an asterisk, which matches any connection, goes at the very bottom, at the end of the file. And this way, the vintage box gets its override done, and all the other boxes and all the other connections benefit from your secure defaults. So this is a manageable thing, and also I have removed the plus sign. Don't use the plus adding thing in SSH config. It will really trip you over. It also might get you into trouble if you have to support some compliance standards or something. And that plus is really easy to overlook, and you'll sit there and not find it. Since -G outputs a lot, it's easy to filter. And if you grab for it now, that vintage box connection only uses the cipher I actually want to use and can use with that old box. It's a lot better now. What if using this way to debug a connection does not help you out either? Because that's not only your config file from your home directory for your own user is applied to that connection. There's also a general configuration in /etc, which is applied to the whole host. And there's also the configuration parameters you pass on the command line. And these are getting set first, so you can always override from the command line. That's a convenient thing. But who has actually looked into their host's default SSH config for clients? Hands up. Who actually did this? Have you ever checked out your distro? 3 hands? Look at it. It's getting applied to any connection you make. And you've never seen what actually happens there. Look at it. It really helps. Other ways to debug your connections. -V for verbose. It's easy. It gives you a lot of output, like which configs are used. It's applying options for a star, an asterisk, and then for a certain connection, and then for another asterisk I have. And it's showing me a deprecated option that's not used anymore. And it gives you even the path of the files that it uses. So if you have multiple SSH installations, for whatever reason that may be, you can easily check which config file, because maybe you had the case already. You're editing some config files, trying again, it doesn't work, you're editing, and then you find out, oh, it was the wrong config file I edited. The edits were fine, just ignored. So this may help you debug some strange behavior on your box, and this can be frustrating. Any questions on that so far? Can we have a microphone? We'll just get you a microphone so that the recording has it as well. Yeah, that is a really old box. It's 5.2. That's an ancient one. Question?
So do you really have over 1,200 lines in your SSH config?
I'm afraid yes. It's a big mess.
Why?
Because I have to manage a lot of boxes. It happens. And yes, I could probably take the time to clean it up and find some more generic configurations that make it easier to manage. Absolutely, yeah. Another question.
So you're saying the defaults are strange. Where can we find some sane defaults?
Well, you can find the strange defaults in the man pages already, so that's something to look at. They're pretty well documented. As for sane defaults, if you watched last year's talk from BalCCon, there we gave a lot of instructions and reasoning on how to derive your own set of ciphers and HMACs and key exchange algorithms, and how to find connection issues that you may end up with. Just watch that video. It's really a long thing. That's not worth completely repeating here because you can watch the video. And as for recommendations, there's something by the Mozilla Foundation, because they host a lot of SSH connections with a ton of clients with who knows what they're using. They do some recommendations. I'm not completely agreeing with all of them. I personally like to have my things a little more strict. But I'll show you how these work. Any other questions on that so far? Nope? OK, I'll continue with something that you can use to test your own SSH service. You may be familiar with SSL Labs and the HTTPS server test to test your websites. You've seen that all. It's a good tool. It's an easy-to-use tool. And it certainly has helped a lot in improving web server security and HTTPS in general by giving you an easy rating. And if it's red, you have something to show to management that you need to do something there. This, of course, applies to web servers on the public internet. How do you deal with SSH servers? Well, there's a tool. It's by Mozilla Foundation. It's called SSH_scan. There are others available as well. And this one, there's a hosted version on the web where you just put in a host name and it scans on port 22. Of course, most SSH servers will either not be available on the public internet, which is a good thing, or not listen on port 22 for various reasons. Security not being one of them, but they're listening on some arbitrary ports. And this tool will only let you use port 22 from the web. Of course, they don't want to be DDoSing anything. But you can use it on your own box and set it up on your laptop. It's written in Ruby, which usually scares the shit out of me, because every time I have to deal with Ruby, I'm investing more time in getting my Ruby fixed on OS 10, because that's a really strange thing to do. But this one actually works pretty well. It has minimal dependencies, so you just clone the Git repo, and it works. Just bundle install, and that actually does work. Works also on any Linux or FreeBSD, and even on macOS, which is nice for me. It's quite a simple tool. You just pass it a host name and a port, and it will scan that one. It does support custom ports in that case, which is good. And it gives you a JSON output report of that host with supported ciphers, connections, version numbers, and all that things. It comes with JSON, so you can easily pass it on to something else for parsing. You can put it into your reporting tool, and it's easily scriptable. So you can also automate this stuff for your compliance reports that you regularly run on the boxes. And it's also quite nicely configurable. It ships with the Mozilla Foundation provided compliance rule sets, policies. They have 3 levels, like a modern one, a standard one, and an old one. Like their CentOS 6 or something, which comes with ancient OpenSSH 5.3, I think. But you can also put in your own compliance policies there. So if you make those, you can match it to the one you need in your company. The project isn't quite in the early stages. Version number is 0.0.27, so that's really early. It's got a lot of rough edges, but still, it's a great tool to already improve and see where the hard things to fix on your boxes are. You install it, it's easy. Gem install SSH scan. If that works, that's fine. If that doesn't, clone the repo, gem install bundler, bundle install, and you're done. The sad thing is it does not respect your SSH config, so you cannot use your nicknames that you already have configured, which is a sad thing. Most other tools that use SSH as a transport or somehow make use of it, like Git or rsync or even FCN, they respect the SSH config. This one does not yet. If you want to add that, it's open source. Please send a pull request. Make it better for all of us. And yeah, you pass it a target and a port. The target, of course, is hopefully your own one, and you're allowed to scan that, or you can also gain intelligence on somebody else's boxes. Please think about what you're doing there. Help to improve those boxes if you find problems. And yeah, you get a nice report. Shows you all the host names. Yes, 5.2, this is ancient, I know. Still makes a good demo. And also the offered key exchange algorithms. There's a lot more in there. And it says, well, for the Mozilla Modern compliance, it fails miserably. It tells me to add these ciphers. As I said, I do personally not agree with these. I would narrow that down and only go for the first ones in each case. But I still get a solid F on that box. So it's on fire. I should not have it on the internet. I should fix it. Yeah. Put that into your system and help to improve your boxes, your friends' boxes on the interwebs and make them better. As for the future, way too fast these days. We're currently on OpenSSH 7.5. 7.6 should be out any day soon. I was already afraid it would hit me like yesterday or so. I would have to update. There has already been a lot of announcing by the OpenSSH project to deprecate a lot of stuff in the crypto side. Your Arc4 and Blowfish, they're already gone as symmetric ciphers. It's a good thing. I mean, for Blowfish, even Schneier, who created this cipher, recommends not using it anymore. That's something probably that tells you not to really not do it. As for RIPEMD 160, as a Mac message authentication, RIPEMD is pretty similar to SHA-1, and we know SHA-1 is pretty rotten, but RIPEMD has not been looked that much into it, so it's quite sane to think about, well, we should probably let it go already. We have faster ones, more modern ones as well. And they will actually be completely removed from 7.6. At the moment, you can still override them at runtime by configuring them explicitly, but future versions, it will just not work because the code is removed from OpenSSH. If you're, yeah, it's a good thing. If you're still using RSA keys, and most of you will at some box have to do this, like your fridge or something, the current minimal RSA key length OpenSSH enforces on you is 768 bits, which of course is ridiculously low now. That will be increased to 1024, which is still ridiculously low. I personally recommend going 4096 on RSA keys these days, on the host and on the client, especially on the host. You may have to recreate your host keys on the server. Who knows how to check how long a server key is on the server? You do? 2 people? Okay. You have heard of a tool called SSH keygen? You generate your client keys with it. You can also generate server keys with that. Who would have thunk? And you can also check a key with, you pass -LF, like list and fingerprint, and you point it to the public key on the server, and it will tell you it's an RSA key of mostly 2048 bits these days, and will give you the fingerprint and the digest and all that stuff. If you find 2K keys on the server, think about telling your clients, your users, we will upgrade that key, we will rotate keys. You will probably have an old key that has survived some iterations of the operating system, upgrade those keys. If you can upgrade the SSH server on that box, you will get some great benefits from going 7.3 and up because they support host key rotation. We've done that last year already. Look it up in a video. It's quite easy. You just add more keys to your to your server's SSHD config, and it will pass those on to the clients. It's really easy. Just get rid of those tiny RSA keys. Even better, go ED25519 as recommended all the time in the last years already. Triple DES is already gone as well, and other CBC mode ciphers like AES in CBC mode will go away as well with 7.6, which is the next update. This means if your server requires CBC mode and you update your client, you will not be able to connect. Have that in mind. Update your configs and your servers beforehand. Be ready for these updates, because updating the client is usually not a thing. It's good to do this. On the servers, your mileage may vary, especially if you're running embedded boxes, which do not run OpenSSH, but BusyBox or Dropbear, or some kind of proprietary OpenSSH implementation and not OpenSSH. Check those in time before you get and lock yourself out by an update that you have not checked before. Yeah, if you can update your server ciphers to Charger 20, it's available from 6.4 and up. Go for that, it's easy. Or at least try to get 6.1, which offers you AES in GCM mode, in Galois counter mode. That's a good cipher as well, it's a fast cipher. At least try to get to those ones. I know Red Hat Enterprise 6 and CentOS 6, that's a problem for you because you're stuck on 5.3. Your compliance causes problems there. Yeah, you have been warned. As always, that's deprecation warnings, and they will become more in the future. So yeah, as I've been way too fast for some reason, more time for you to ask questions. Microphone.
Can we break the bad crypto at home?
You mean
3DES and CBC?
breaking triple DES? I don't think you'll easily break an SSH handshake with that. But still, CBC modes have shown a lot of trouble in HTTP connections, and you don't want to be on CBC mode already if somebody finds a way to apply those attacks to SSH connections as well. SSH connections are much better protected against these attacks than HTTPS is, for example. But still, you want to be ahead and try to get rid of those in time.
So I do get what the keys and the ciphers do, but what does the MAC do exactly?
The MAC guarantees the integrity of the messages, so that what the client receives actually is what the server sent, or vice versa. So that's the integrity of the message, and if you have some packet loss or somebody's injecting traffic or manipulates your traffic, the server will not accept manipulated packets, and this is detected by the MAC.
So
or if you use
a checksum. A checksum.
It's actually an HMAC based, so it's a signed checksum, but pretty much yes.
Hi, I have two questions. What's your opinion about compression?
On compression, okay. Compression is used in two different parts of an SSH connection, the one being the handshake itself. Old versions of SSH did compression there, and we all know during a handshake, using compression has bitten us with TLS already. So OpenSSH, since I'm not certain about the version they deprecated this, is not using compression during the handshake phase, which means the early phase of the SSH connection. So you're safe from those attacks. And SSH has, I think with 7.5, completely removed the configuration to change this. And it has been that way for quite a few years, so that's a good thing. And after that, you have the compression on the data that's transferred. Personally, I'm fine with that. It usually helps to speed up your connection since gzip is quite fast on modern CPUs and can be quite nicely parallelized. So for like an interactive terminal, I would recommend using it. If you have a lot of data transfer, like backing up a machine over SSH that is on a high-speed link, you might run into trouble. That is something you can easily performance test with PipeView and SSH to see if the compression bottlenecks you or the crypto bottlenecks you at some point. Something I absolutely cannot recommend when you're using, for example, rsync, which is a common thing to use over SSH. Configuring rsync to compress and configuring your SSH connection to compress. Now you have a lot of overhead and your connection slows down. And you can easily leave that compression default in your SSH config and actually tell rsync to tell SSH to not compress and still compress in rsync. So rsync can tell the underlying SSH connection to remove that SSH compression because our rsync knows more about the data and can compress better. So that's a nice trick you can use without changing your config as a default and still get the benefits from rsync compression.
And that was going to be my second question about if it is a good idea to change the ciphering algorithm on rsync to use a shorter key algorithm for large data.
I personally would not mess with those in rsync. I just use the ones from my SSH config, and rsync uses that one. Also, it makes it easier to use. You may want to be interested in changing the symmetric cipher in rsync for performance reasons. There's even some high performance patches for SSH and the underlying transport to rsync. I think FreeBSD ships with them by default. And there's other operating systems, especially storage-oriented ones, that come with patched SSH versions that even allow a null cipher. They still do an HMAC on that, so you still have the integrity, but you can actually turn off encryption completely. I would not recommend doing that, not even on your LAN. Usually the encryption is mostly not your bottleneck, so I'd rather not mess with the authentication methods there. Okay? More questions? There's one.
Is the Heartbleed exploit still viable? And if it isn't, are there any alternatives?
Is which exploit?
Heartbleed.
Heartbleed. Heartbleed does not apply to SSH. It's for HTTP.
So you mentioned changing the cipher for rsync. Chacha is for regular SSH, and what would you recommend for data transmission?
I'd be fine with Chacha.
It's doing good.
It's a great cipher. It's a fast cipher. In special cases where you have a low latency, high throughput link, that you might get some better performance by going AES GCM. That's something you need to test because it also applies to the with the compression settings and to the very specific data you're transferring. If that compresses very well or not. That's really something you need to try with your own data and your own setup with that specific connection. It's easy. You can try to connect with Chacha 20 or with AES GCM and see where you get better performance. To do a speed test over SSH, it's quite nice if you know about PipeView. It's called PV. It's a command line tool, and you can just put that in the copy pipe of your cat sum file and pass that on to SSH. And PV will give you the throughput you actually manage to get. So you do cat to large file, use maybe a specific compressor like XZ, which does a better compression than gzip. It also eats CPUs for lunch.
Yeah.
But if you have a box that's idling with 36 cores, make use of that by using XC for compression and turn off the compression on the SSH connection. So that might give you a lot of more performance than changing the ciphers.
You also mentioned that rsync does its own compression independently, if I understood correctly. So if I, for example, disable SSH compression when using rsync, I should not compress my files before piping them to rsync, right?
Yeah, only use compression in one step, either before piping them into rsync by using XZ.
And then disable compression for
and
everything?
Don't use don't compress twice. That usually goes badly.
Okay.
If you benefit from XZ, that's fine. Use it before it, and don't compress in rsync and SSH. If you just want to use the SSH, the rsync compression, which is -Z, I think, that uses gzip, just like SSH does. But either use the SSH compression or the rsync compression. Using both will get you bad performance, and rsync usually knows a lot more about the data, so it compresses better than SSH. Also,
is better sending a folder recursively with all the files, or tarring the folder and then sending it?
Usually, if it's a lot of files, you're faster with tarring it beforehand, because you get a lot less directory access on the target side. But you might not be able to tar it before, or you have to untar it on the other side as well if you're actually trying to sync a folder tree that may or may not apply to the use case you actually have. So, but if it's just a one-time transfer, tarring before usually gives you a small benefit.
Thanks.
Yeah.
You mentioned SSL Labs online tests. There's a CryptoSense something discovery that also tests SSH parameters.
Okay.
I don't know. Have you used it? Does it compare to these service recommendations?
At the moment, I'm not sure if I know about this specific one. Please come to me afterwards and hand me a URL. I'll check it out. And
Okay.
If you have some time after the workshop, maybe, I'd like to talk to you about it. It's interesting.
Hello. Do you have any tips on your key management?
Key management. Who? Client or server? Client keys or server keys? Both. Okay. For server keys, if you're on SSH 7.3 or higher, you can make use of the modern host key rotation features that SSHD offers, which means you can have multiple host key lines in your config of the same type or of different types. And the SSH server will actually pass those on, and all of them to the clients if they are 7.3 and up as well. So if you have some requirement for regularly rotating those, that makes it a lot easier, because you don't need, if your clients regularly connect within your rotation interval, they automatically get pretty much pushed down the new keys and know about them beforehand. On the client side, you can configure if you accept those keys, because they get after a successful handshake with a known key, so you already have an authenticated connection, they get pushed down to the client, and the client can decide by itself to accept those keys without asking the user, or by prompting the user, there's new keys, do you want to save them in your known host file? And then it does it. Or you can also configure the client to just refuse those, and then you're still with manual management. As for the client, I don't really have a good suggestion. Microphone, please.
Do you use a queuing, your client's machine queuing?
I do use some keyring functionality on my laptop, but I don't really make a lot of use for it for key rotation. I try to get rid of older keys like DSA keys. I've by now phased them out completely. I still have some RSA keys, and I usually try to not reuse keys. So I personally use for one client or one, like GitHub, I have an RSA key, an old one I still have as a backup, and an ED25519. And I have a bunch of keys, but I do not reuse them. But as for rotation, I don't have a good recommendation for you. If you have some thoughts of that, I'd like to talk to you afterwards. More questions? No? Yes? No? Some? No. Doesn't look like it. Okay. You get to finish early and have some time to drink more coffee. Thank you.